So the ground truthing for all of the soil moisture measurements really come down to the gravimetric sampling, where we can take the soil's bulk density as a characteristic that's been measured and calculated. We can take an initial weight of the soil when it's wet, extracted from the field, dry it out, where we essentially pull the water out of it, and then we have the soil's dry weight. The difference is the total water that's extracted, so we end up with this gravimetric, or a weighted sample of how much water is actually in the field. We can combine that back with total available water, plant available water based on pressure characteristics in the soil, and actually end up with a number for how much water in terms of inches is in each incremental foot of soil. Okay, so our process and our apparatus is we will measure out into weighted cups a general volume of wet soil that's been extracted from the pit or from a dig or from a probe extraction. In this case, it's from a pit. And so we've got the cup, the wet soil goes in it, we've got a measurement on the cup, and we've got the measurement of the soil. Like in this case, it's 33 grams. So that 33 grams will be recorded, the cup will be removed, and then this will go into, in this case, because we're taking the shortcut on it, we'll put it in the microwave at low temperature, extract the water, and then we will go through this process again of measuring the dry weight, and then the difference between that will ultimately be a volume of water that we can use to calculate the total volume of water that's stored in the soil. This is the gravimetric sampling. Now, this isn't practical for a farmer to use in day-to-day management, but for us in this, if you will, a research type situation where we're trying to prove up, one, exactly how our water management is working. We need to know an exact volume of water that's been extracted, so we really need that measurement. But it also allows us to use measurements side by side to calibrate probes. So we can calibrate different types of probes, whether it be a gypsum block, whether it be an aquaspy probe or a Grow Guru probe or a trellis probe. What we'll be able to do is take this information that we've gathered from our actual digs and actual field data, correlate it to responses on the signatures of those probes, and with some confidence know how well those probes are working. And the beauty of those probes, they show you great trends, they show you real-time information. The drawback from those probes is they don't give you highly accurate volume information